Heat pump water heaters. All right, anybody? So how does a heat pump work, by the way? What does a heat pump do? Heat pump. It pumps heat. A heat pump pumps heat, just like a woodchuck chucks wood, almost. And it does the same thing as an air conditioner. In fact, an air conditioner is a heat pump, but it pumps in only one direction. When we refer to something as a heat pump, it can actually change direction. In the wintertime, it pumps heat the other direction. So in the summertime, what's your air conditioner doing? It's pumping heat from where to where?
From inside to out.
Inside to outside. So in wintertime, it's pumping heat from outside to inside. Even when it's 30 degrees outside, it's pumping heat from outside to inside. From where it's 30 degrees to where it's 70 degrees. And it is possible to do that. I have a heat pump in my condo. It works. We can pump heat from cold places to warm places.
That's what the refrigerator does all the time.
A refrigerator is a heat pump. It pumps heat from the cold inside to the warmer outside. So that's what heat pumps do. A heat pump water heater, where is it pumping heat from and to?
Maybe the ground, or it depends, doesn't it?
Not the ground. Oh, I guess you could maybe set one up to do that, but they typically are pumping heat from the air around them and pumping it into what's in the tank? Water. So this thing has a heat pump sitting on top of it. And this isn't hooked up, but if it were hooked up, you would hear a little bit of noise, like you do with a dehumidifier, because a dehumidifier is also a heat pump. But it's actually not pumping heat from one place to another. It's keeping all the heat in the same place and adding a little bit more because it's not 100% efficient. But a dehumidifier is mainly set up to dehumidify. Anyway, the heat pump water heater is pumping heat from the air into the water. This whole top section is a little heat pump, like a dehumidifier, with the compressor and the coils and everything. So it's pumping heat from the air into the water. So what happens to the air around the heat pump water heater? It gets cooler. That's a good thing in summertime. The air around the heat pump water heater also gets drier because it's doing the same thing as an air conditioner does. It will help dehumidify. So a heat pump water heater dehumidifies, it cools the air around it, and it puts heat into the water in the tank. So that's pretty cool. It's a neat technology. And they do make a little bit of noise, so you don't want to have it right in your bedroom probably, but typically it's not very loud, and it will be generally quieter than the air handler for your air conditioner. If you have the furnace or air handler like in a laundry room or something, you can hear it when it comes on, a heat pump water heater is going to be quieter than that. Probably be similar to a dehumidifier and the amount of noise it makes.
Do they cost a lot more than
a regular water heater you can buy for $300 to $500. Heat pump water heaters run maybe $1,500, $2,000 or more sometimes, depending on the water heater. I don't know what Bosch's run, but they are more expensive. They are a lot more efficient, though. A lot more efficient, especially if you are if you're already using electricity. If you have an electric water heater, an electric water heater is 100% efficient, almost 100% efficient. There are some little losses, but it's close to 100% efficient. It's 100% efficient at turning the electricity into heat. It's not 100% efficient at getting that heat into the water and keeping it there because the tank loses heat. So the heat pump water heater is, on that same scale, about 300% efficient. So it will use about a third the electricity that a standard electric water heater uses. If it's a true instantaneous water heater, it's going to be a small unit mounted right there at the fixture. And those are more efficient. Well, it depends on how you're getting the energy. But you get rid of the distribution losses there. One of the big losses in hot water systems, which we haven't really addressed in a lot of the programs, the green building programs, energy efficiency programs, is the distribution of hot water. because a lot of houses will have a hot water, the water heater on one side of the house, and then you've got a bathroom on the other side, and you've got a long run for the hot water, and you've got a lot of distribution loss there. And not to mention the waste of water when you turn on that faucet and wait for the water to get hot. So, yeah, distribution losses can be big. So a true instantaneous water heater where you have a small water heater at the faucet helps eliminate that. But you can also get rid of that with better design of the bigger system. And generally the bigger systems are better overall for efficiency.
Are you talking about tankless systems?
Tankless or heat pump water heater. Yeah, when we talk about tankless, generally we're talking about gas. When we talk about heat pump water heater, generally we're talking about, we are talking about electricity. So
But which one's more efficient or is it better?
they're both comparable in terms of efficiency. If you go with the higher end on them, you can get them in a range of efficiencies, of course, but they're comparable. Yeah, water heater is an interesting subject.
So, I'm from Louisiana, we used to use
Oh, me too.
electricity a lot.
Uh-huh.
So what do you do when your electricity goes out? You just don't have hot water?
Well, you have a solar system, photovoltaics on the roof, and a backup battery bank so that you can power the essential systems while the electricity's off.
And the
Or you have a generator.
backup system is run off solar panels?
Mm-hmm. Yeah. When you have photovoltaics on the roof, there's different ways to do it. You can have them just wired directly in with the grid without any batteries. But if the grid goes down, then if it's sunny out, you've got electricity in the house. If it's not sunny out, you're out of luck. If the grid goes down in the dark and you don't have a battery bank connected to your solar panels, then you're not going to have electricity either. So,
What kind of batteries are those attached to that?
what kind of what?
What kind of batteries are those that store the energy?
There are a lot of them. They're like golf cart batteries. And some people do use actual golf cart batteries for these systems. But there are specialized batteries as well, and some of them are very large. They hold a lot of energy. All right. So heat pump water heaters are great technology. Tankless water heaters are great technology. Ground source heat pumps. Remember, heat pumps move heat from one place to another. In a heat pump water heater, you're moving it from the air around it into the water in the tank. In a ground source heat pump, you're moving, in the summertime, you're moving heat from the house into the ground. And the way it works is you've got these loops buried in the ground, so you're running a fluid through these loops, and it's exchanging the heat with the air in the house. And this is one of the wells drilled. Well, I guess technically the ground source heat pump industry calls these boreholes, not wells. They're trying to get rid of that word well from this technology because water wells have all kinds of restrictions placed on them, and they're saying we shouldn't have those restrictions. Anyway, this is the borehole for ground source heat pump. This is actually one of the 20 boreholes or so for a ground source heat pump at Al Gore's house. I was there 2007, and he was getting a complete retrofit of his house with all new windows and spray foam insulation and encapsulated crawl spaces and ground source heat pump. So ground source heat pump is pretty cool technology. Mini split heat pump is another one. They are air source heat pumps, so they've got the indoor unit and they've got the outdoor unit. The outdoor units on these, though, are a lot quieter than the typical air source heat pump. If you ever see one of these, and they're easy to notice because they're very thin. The standard air source heat pump has a big square metal box or rectangular, and they're very loud. These have the very different profiles, very thin. Looks like a kind of a suitcase, and very quiet. You can, the standard mini split heat pump is a ductless model, and if you see something like this in a house or a building, that's the ductless head. So that's where the heating and cooling happens. It's connected to this by the refrigerant lines that run the refrigerant back and forth between these two. You can also have a ducted mini split where it's got this kind of condenser, and it's very high efficiency. It's variable capacity as well because the compressor can change how much refrigerant it's sending through the refrigerant lines. So you can have ducted system with these as well. So mini splits I think are very cool, very high efficiency, quieter than the typical unit, not as quiet as a ground source heat pump because there is a little bit of noise, but a net zero home. So this is one in Serenbe, and this is I think Bosch's net zero home here at Serenbe. It's got solar panels, so you're generating enough energy to offset the amount of energy that the house uses. I have some friends up in Asheville, North Carolina, and they have a net zero home. They also have seasonal electricity rates from their utility and time of use rates, and so they put a note on their dryer to remind them when not to use the dryer, because if you have a net zero home, there's two ways, I mean there's different ways of defining that we talked about earlier, but there's also net zero as designed and net zero as lived in. And they've found that to get actual net zero performance, they have to do certain things in the house differently than they normally did. So they pay attention to what time they run the dryer, and that helps them get the net zero performance. All right, and this, I like to put this in all my presentations lately because this is why we want good homes. It doesn't have to do with the technologies and all these benefits I talked about in the abstract. It has to do with the way we live in houses. We live in houses, we love in houses, we raise children in houses, we cry in houses. This is where we live our lives. You know, we spend about 90% of our time in buildings, right? The first time I heard that, I was blown away. I said, there's no way. And then I thought about what I do, and I said, well, okay, maybe so. I need to spend more time outside. So anyway, this is, I think, the real benefit of having a green home. So the children can enjoy life and dance and be in harmony with art. So I read a blog, in case you didn't know that. It's called the Energy Vanguard blog, energyvanguard.com. You can go there, you can read all kinds of articles. I've been writing it for almost 4 years now. I've got over 500 articles, write about 3 a week. I'll probably have one this coming week about something about Serenbe. And energyvanguard.com. Here's my contact info. And thank you very much for coming on a Saturday afternoon.